Welcome, ladies and gentlemen, to some extra practice when it comes to our special right triangles. In today's episode, we'll be comparing and contrasting the 30-60-90 versus the 45-45-90. And just for this, just a quick little reminder, I started off with a diagram of both types of triangles. And so remember, the 45-45-90 right triangle, the isosceles, is x, x, and x rad 2. Meaning the legs are going to be identical all the time, and then the hypotenuse is going to be one of the legs times the square root of 2. The 30-60-90 right triangle follows more of a fast food pattern where you have a small side, medium side, and a large side. Remember, the small side is always opposite the smallest angle, which is 30. The medium side is opposite the medium angle, which is 60. And the large side is opposite the large angle, which is 90. And so one of the consequences of knowing your special right triangles is having to do a special right triangle without all the information. And so one of the first things they're going to do with a problem like this is they'll throw a triangle at you that only has a piece of it. But it's up to you to figure out all of the other pieces. So off the cuff, because this angle here with the box is 90, and this side here on the bottom is 30, by default, because of the degrees that total a triangle, the top angle has to be 60 degrees. So from here, what I'm going to do is I'm going to give you a side length. I'm just going to give you a side length of 4. Now, in this particular 30-60-90 right triangle, remember, identify the type of special right triangle you're dealing with first. We're dealing with a 30-60-90. How do we know? Because one of the angles was measured at 30 degrees. The problem gave that to me. So they gave me the 4 here. Now, where is the 4? The 4 is opposite of the 30, meaning that this 4 is the small side. What I need is the medium side, and then I need the large side. Let's go and call the medium side, let's go and call that X, and let's go and call the large side, we'll call him R. So remember, the small side is 4, right? So in other words, 4 would go in my first colon if I wanted to structure it this way. Well, the medium side is always that exact same side, in this case being 4 times the square root of 3. So that's what X can equal. It's 4 times the square root of 3. Based on our ratios. And then the large side R is always double whatever the small side was. Well, what was the small side? The small side was 4, which means the large side has to be 8, because 2 times 4 is 8. So at the end of the day, your answer would be X equals 4 rad 3, and R would equal 8. And you'd be done. So special right triangles really do allow us to move quickly through different types of right triangles. The problem is they will often take away information from you when doing a special right triangle, so it's up to you to kind of figure out what pieces of information that you need. So from here, let's go and take a look at this triangle real quick. So I'll go and call him 7 down here. Now again, notice the type of special right triangle we're dealing with. Notice the tick marks. The tick marks are going to tell me what type of special right triangle this is. Go up to the diagram. This is a 45-45-90 right triangle, and I know that because of the tick marks. The tick marks say that the sides are identical. And let's go and solve for what they want us to solve for. I'm going to call this side, I'm going to call him Y, and I'm going to call the hypotenuse R. Well, notice the ratio. The ratio on a special right triangle that's 45-45-90 is it goes X, X, and then X rad 2. So that means that the Y has to be 7. And then R is going to be one of the legs. It doesn't matter which one because they're both identical. So 7 times the square root of 2. And that's it. That's how you deal with a special right triangle that's 45-45-90. Give me a second. I'm going to clear off the board, and then I will come back with a few more examples. Okay, here comes the next example, example number 3, where we have this type of right triangle. Now, notice how I've taken away some of the information this time. I haven't given you all the angles, but it's actually going to be our job to figure out the measure of this angle. Luckily, we should know it. It is, in fact, 60. Which means, what sides have we been given? We were given the 7, and the 7 is opposite the 30-degree angle. In other words, the 7 is the small side, right? We're dealing with a 30, 60, 90 right triangle. Notice I don't have any congruency markings here, so this is 30, 60, 90. My 7 is across from the small side. So I better find the medium and large side. How do I do that? Well, the medium side is always the small side times rad 3. Well, the small side was 7, rad 3. And then the large side was always double the small side, so I end up getting 14. And that's just it. Y equals 7 root 3. R equals 14. All right, I'm going to put a few examples up at the same time now. I'm going to remove the diagram, so hopefully... All right, I'm going to put a few examples up at the same time now, so we can kind of fire through these. Give me a second. And here we go. 4 more examples for us to do. So look at this first example here, number 4. Notice the angle measure. We have a 30 here, meaning we are dealing with a 30, 60, 90 right triangle, just like in our diagram. So we will not reference the 45, 45, 90 right triangle in example number 4. We're dealing with a 30, 60, 90. So from here, what side did they give us? Well, they gave us a 12, and the 12 was opposite the 30-degree angle. So this angle has no choice. It's got to be 60, which means X is my medium side. Well, what is the medium side at all times? The medium side is always the small side times the square root of 3. And I'm hoping you're beating me at some of these things that I'm saying. R. Well, R is the longest side. Well, how do I find the longest side? Well, again, look back up at your diagram. R, which is the longest side, is always double the short side in a 30, 60, 90 right triangle. Well, the short side, again, was 12. So 2 times 12 is 24. So your answers should be 24 and 12 rad 3 for R and X. Moving on to number 5. What type of special right triangle is it? It's an isosceles right triangle, a 45, 45, 90 right triangle. How do I know? It's because of these tick marks that exist inside the lines, which show that the two sides are congruent to each other. And if the two sides are congruent to each other, then the two base angles will also be congruent, identifying this as a 45, 45, 90. Well, how does that help? Go back to the diagram up top. Well, remember, the side ratios in a 45, 45, 90 are X, X, and X rad 2. So if this side here is 22 units long, this X has no choice. It's got to be 22. And that makes R 22 times the square root of 2. All right, let's take a look at number 6 here. Now, number 6, again, notice the type of triangle we're dealing with. We're dealing with a 45, 45, 90 right triangle. How do I know? It's because the two sides here are congruent to each other, meaning the two angles here are going to be congruent to each other, making themselves both 45 because of the 90 here. Well, in this case, this one's a little bit different in the sense that this time they gave you the hypotenuse first and are expecting you to solve for the sides. So how do we do that? Well, the way we do that is we have to establish a relationship between how we got from one side to the next. And in this case, how we got from the leg to the hypotenuse. Well, if you look back at example number 5 here, this 22 here was a leg of the isosceles right triangle. The hypotenuse was this 22 rad 2. So how did the 22 become 22 rad 2? In other words, how did the leg become the hypotenuse? Well, what we did was we took the leg and we multiplied him by rad 2 to get the hypotenuse value. So we have to almost reverse engineer that idea when going from hypotenuse back to leg. So again, I go back to the relationship. I took the leg and I multiplied by rad 2. Which means if I'm going to go from hypotenuse back to leg, I will then take the hypotenuse and divide by rad 2. And that's going to get me the leg back. So if I do that, that means that I'm going to have 7 root 2 divided by root 2. Again, hypotenuse divided by rad 2 gets me in backwards motion back to the leg. The rad 2's are going to cancel each other out, giving me 7 and 7 here because of the identical tick marks. So remember, guys, in a 45, 45, 90 right triangle, when moving from leg to hypotenuse, we multiply by rad 2. In order to move backwards from hypotenuse back to leg, we divide by rad 2. That's going to play a big role in the next set of examples. Not this one, but the next set, although this one's not totally unrelated. What type of triangle is number 7? A 30, 60, 90. How do we know? Because there's no tick marks here showing me duplication in the sides or showing me the same measurements in the sides, and I know that this thing is 60, leaving me no choice but to call him 30. This time it's a little different. It's similar to number 6. They gave me a side that had a rad 3 in it. So from here, where is this side? Well, it's opposite the middle angle, so this is my middle side. So similar to how we tackled number 6 with the leg to hypotenuse and then hypotenuse back to leg, I can make the same relationship here. Remember, if I look at the original diagram here, the 30 is the small side, or the small angle, sorry. The 60 is the medium angle, and the 90 is the large angle. So how did I move from small to medium? Well, the 30 became the 60, that's obvious, but the sides became themselves by taking the small side and multiplying by rad 3. In fact, I'm going to write that down. So in a 30, 60, 90 right triangle, the small becomes the medium by multiplying the small by rad 3. Small becoming medium by multiplying by rad 3. So, how would we go from medium back to small? Well, I hope you can pause and try and figure it out, but if you can't, it's no big deal. We would take the medium, and remember, we're moving backwards here. Remember, small to medium was multiplying by rad 3. Which means medium to small is going to be medium divided by rad 3. So that's how I'm going to tackle this problem here. This y value is now going to become 6 rad 3 divided by rad 3, giving me just 6. Once I have the small side, getting the large side is easy. He's just double the small side, so that's going to become 12. Hope that makes sense. I'll be back in a few more examples. And here come the final 3. So here comes number 12. First off, identify the type of right triangle that you're dealing with. This is a 30, 60, 90. How do I know? One of them's 60. The other one's got to be 30. So I'm going to kind of fly through this problem a little bit, but before I do that, notice the side they gave you. They gave you the hypotenuse side, which means you're starting off with the largest side. So how do we solve y and x? Well, the first thing you might want to consider doing is finding the small side. The small side is opposite the 30. So remember, the large side is always double the small side. Another way of looking at that is that if the large side is always double the small side, then the small side has to be 1/2 of the large side. And if the small side is 1/2 of the large side, then half of 18 will become 9. And then to get from the small side to the medium side, we just take the small side and multiply him by rad 3. And we're done. Moving on to number 13. Check out this triangle. It's a 45, 45, 90 right triangle. Again, look at the tick marks. We know the sides are congruent. The problem is that the hypotenuse, notice what's missing. It doesn't have a rad 2 next to it. It doesn't always have to have a rad 2 next to it. In fact, if the book really wants to mess with you, they will not put a rad 2 here. But remember what we talked about in the previous couple of examples. If we move from leg to hypotenuse by multiplying by rad 2 on a 45, 45, 90 right triangle, then to go from hypotenuse back to leg, we take the hypotenuse, which in this case is 4, and we divide by rad 2. Just think about it going backwards. So to go from leg to hypotenuse, leg times rad 2. To go from hypotenuse back to leg, hypotenuse divided by rad 2. X and y are going to be the same value because of the congruency tick marks. Same deal goes for number 14. Again, 30, 60, 90. How do I know? They told me it was. Notice what's opposite the 60. Just 8. What are we used to being opposite the 60? Something that has a rad 3 attached to it, except this time it doesn't have a rad 3 attached to it. So, is that allowed? Of course it's allowed. We're just talking about numbers here. So what I'm going to do is, remember, I have to think about how do I move from small to medium. By the way, small is opposite this 30-degree angle. So to go from small to medium, I multiply the small side by rad 3. To move from medium back to small, I'm going to take my medium side, which is 8, and then divide him by rad 3. So again, we're just talking about reverse operations here. Just think about going backwards and going forwards, like in Darkwing Duck, potato versus otatop. It's the same, thing, but going backwards. How do I move from the small side, which is opposite the 30, this 8 over the square root of 3? What do I do with him? I double him. I do that by multiplying by 2, or more precisely, 2 over 1. What I get is 16 over the square root of 3. And I think that just about does it for all these examples. And so hopefully this is enough to help you out and get you guys started with the homework. And I will see you in the next episode.